The final element of our game is the ability to force a certain direction on the spinner. Usually, casinos don't like it when you grab the wheel and force it to stop, but we probably shouldn't be gambling much anyway. This time, our function is going to consume not only a spinner, but also a key event. Recall that we learned about key events in the previous lecture. They represent keys being pressed on the keyboard. The four relevant keys for our game are up, down, left, and right. So let's make a quick enumeration for this. We say that a key event is a string, one of, up, down, left, or right. And we'll give an interpretation of what this means. It's the key being pressed on the keyboard. Now we need to create a new function, handle key, that consumes a spinner and a key event. So we're consuming the world and the key being pressed to change that world. And then we're going to produce a new spinner based on that key. So we'll say handle key is a function that consumes a spinner and a key. It produces a new spinner. Giving a brief explanation, consumes a spinner and a key event, produces a new spinner based on the key pressed. Then we can stub out our header. Handle key consumes a spinner and a key. We get dot, dot, dot. The examples are relatively easy to write, but reveal an interesting fact. The result of calling handle key is going to be entirely dependent on the second parameter. And the first parameter is actually irrelevant. Didn't have to be that way. We could have designed our game differently. For instance, we could have made it so that pressing the up key just rotates the arrow 90 degrees from where it is. Pressing the down key rotates 90 degrees in the other direction. But this is the game we originally specified, so we're going to keep building it as it is. So we say that we handle the key if the current direction of the spinner is north and the user presses down, then we expect that we will end up with pointing south. We can make a few other examples to try and get some good coverage of the different possibilities. We'll do another one for north. We say if the user presses up when it's already north, it stays north. If the user is in the down state, the south state, and presses left, then we force it to be in the west. And if they're in the east state and they press right, they'll stay in the east. So we're trying a few different cases here, a few different combinations, but we're making sure that we try every possible combination of the keys at the very minimum. Relying on the information that we're just using the second parameter, we follow the design template by building a conditional with 4 clauses, but each one is representing the key events, not the spinner. So we have our 4 clauses, and we need to ask string equal a key is equal to up. Then we'll do something. And we've got 4 of these. Get them all aligned right over here. We'll handle the up, down, the left, and the right. And if the user presses up, the new spinner, the new world state, is going to be north. If they press down, the new state is south. If it's left, then it's west. And if it's right, then it's east. Depending on which key is pressed, we're going to create a different spinner. And we'll run our unit test just to make sure that everything's working, that we have full code coverage. And we notice that we left a parentheses off. See, we expected our end parentheses to close and open parentheses. Probably messing up our indentation before line 81. They were spot on. We missed it right here. So let's try running again. And now we get that all 12 test cases passed. So we're doing good. We could have added more test cases. We have full code coverage, but if we were paranoid, we could have tried every possible combination of spinners and keys. But, it's all about confidence in yourself. It's all about how correct you think you are. If you start having problems with the handle key function, you probably add more test cases. For now, this should probably be enough.